Notice this uses a ratio. Okay, PQR is a triangle with sides lengths in the ratio 4 to 5 to 6. The perimeter of PQR is 60. Now let's talk about what a few things here mean. Perimeter means the distance around the outside. So it's if I add all three sides together, their lengths. So if I added the length from P to Q plus the length from Q to R plus the length from P to R, it's going to be 60 feet. The ratio here, 4 to 5 to 6, means they have some common factor, and 4 times that number is one of the sides, 5 times that number is the second side, and 6 times the number is the third side. So I'm just going to go ahead and label my triangle. This is the shortest side, so it's going to be my 4x, and again, that's for our common factor in our ratio. Here's the next longest side, that would be my 5x. And finally, the third side I labeled 6x. Those are my three sides. So as I look at my problem, I remember, well, when I add those three sides together, I am supposed to get 60 feet because that's my perimeter. So let's put that in. So if I take 6x and add 4x and 5x, those are my three sides, I should get 60 feet. Combine your like terms. So we have a 6, 4, and 5x. They're all x's, so we can add those together. We get 15x equals 60. We want to go ahead and solve this equation. It's 15 times 60, so we do the opposite of multiplication and we divide. 60 divided by 15 gives us 4. Our x is 4. Okay, so that's the common factor they all have in common. This side is 4 times that number. Our next side is 5 times that number. And our final side is 6 times that number. So this would be 6 times our common number 4, or 24. This side here is 4 times 4, or 16. And this side is 5 times 4, or 20. We now have the lengths of all of those sides. They wanted the length of the shortest side, so our shortest side was 16. Okay, this one is very similar. It's a rectangle instead, however. So let's take a look. The ratio of the side lengths in a rectangle are 4 to 3 to 4 to 3. That's because you have two pairs of equal sides in a rectangle. Let's go ahead and try and draw out a rectangle. Okay, so again, when it's in ratio form, that means there's some common number x, that 4 times that number is one of the sides, 3 times that number is the other of the sides. So I'm going to label my rectangle as 4x, 4x, 3x, and 3x. The area, now this time we're dealing with area. The area is 432 square feet. So how do we find the area of a rectangle? Remember? The area of a rectangle is the length times the width. So here we have a length and width of 4x and 3x. Our area is supposed to be 432 square feet. Our length is 4x. Our width is 3x. So we have length times width equals the area. Go ahead and multiply. 4 times 3 is 12. X times x, when you multiply, it changes your exponent as x squared, and we solve from there. Okay, first we need to get rid of that 12. So we're going to divide both sides by 12. We get 36 is equal to x squared. Now we want to do opposites when solving equations. The opposite of x squared is squaring an x is doing the square root. So to solve this, we do the square root of each side. So we're basically asking what number times itself is 36. And it's either 6 or negative 6, but this is length of a rectangle, so 6 is really our only option. So this is our common factor. Okay, that's the common thing we have that created our ratio. They want to know what are the lengths of the sides. So we go back and put that back in here for our x. Substitute back in. this side would be 3 times 6, which is 18, and the bottom here would be 4 times 6, which is 24. So the lengths of our sides are 18 and 24. Right, here's one more of those types of problems. This one is dealing with another situation. We're talking about angle measures this time. So it says in a quadrilateral 2, 3, 4, and 6, 2 to 3 to 4 to 6 are the lengths of the sides. So quadrilateral means any four-sided figure. So that, for example, could be our situation. Okay. We're talking about angle measures, which are not the lengths of the sides, but the lengths of the size of the opening of the angle here. Okay, so this time we're going to label in the corners because it's our angles we're talking about. So one of them is 2x, one is 3x, one is 4x, and one is 6x. Now I didn't necessarily label those the way they should be, but I have all of my figures there. They want me to find the measure of the largest angle. That would be the one with a 6x. But we need to know something about angles in a quadrilateral. Now, in the first semester of geometry, we talked about four-sided figures have a total of 360 degrees. Triangles had 180. Four-sided figures, quadrilaterals, have a total of 360. So when I add all four angles together, I take angle 1 plus angle 2 plus angle 3 plus angle 4. All together, those total 360. So let's do that because we have to have an equation to solve for our x. So our 360 is equal to 2x plus 3x plus 4x plus 6x. And we go from there. We have common factors here we're adding together. They're all x's, so we can go ahead and add them. 2 plus 3 plus 4 plus 6. How many x's do we have total? We have 15. We then continue to solve. We have 15 times x, so we do the opposite of multiplying, and we divide both sides by 15. And we get x, our x is 24. So what we can do with that is go back up into our figure here and find the measure of each angle. This one would be 2 times 24, or 48. This angle would be 3 times 24, or 72 degrees. These are all degrees. They're angle measures. So it would be 4 times 24, or 96 degrees. And our final one would be 6 times 24. This is our largest, I know because it's the 6 times, or 144. So for this example, our largest angle, that's what they wanted to know, our largest angle was 144 degrees. So key things we had to know here is that we were talking about angles, so we were talking about the corners, and that the total degrees, the total angles inside a quadrilateral are 360.